Welcome to the lecture on transformations of functions and graphing. We're going to start our lecture today on talking about four major graphs that you want to know very well and have memorized. And we're also going to talk about the domain and range of these particular functions. So the first one we're going to start off with is a very basic linear function, f of x equals to x. And you should know that the graph of this is just a line. Since there's no plus b on the end, the y-intercept is 0, and the slope here is the coefficient of x, which is 1, so we're going to go from 0 up 1 over 1, up 1 over 1, and so on. So that's why we get a line of slope 1 through the origin. The domain of this function is all real numbers, because every x is used if I look across that x-axis, and the range is also all real numbers. Because of these arrows, I keep going up and I keep going down. So my domain and range is all reals. The next major function that you want to know very well is the quadratic function x squared. And x squared just looks like a parabola that points upwards. One of the things that I suggest to students is to memorize the pattern that is going to be used for x squared. Once you know where the vertex is, then you're going to take from that vertex and go over 1 to the right and 1 to the left and up 1 on both sides. And that gives us 2 side points. If you wanted to continue the pattern, we'd go over 1, up 3, and we could even go over 1, up 5. And this is how we get all the side points on our parabola. So I'm going to go over 1, up 1, over 1, up 3, over 1, up 5. And that gives us these 5 major points that help us to sketch any quadratic. So if you want to memorize that pattern, over 1, up 1, over 1, up 3, over 1, up 5, it will give you a nice simple way to graph a quadratic without doing a lot of point plotting. If we look at this graph, the domain of this particular function is going to be all reals, because I can use any x that I want. There's no restrictions on x. And the range, if you look up and down here, the range is your y values. The lowest y value that this goes through is 0, and I go up from there. So the range is going to be 0 to infinity with a bracket around the 0. For the next major function that you want to know, we have the absolute value function. And this looks like just a great big V. And if you notice the pattern here, the vertex is right here at the origin, and from there I go over 1, up 1, over 1, up 1, over 1, up 1 each time. So the pattern would be over 1, up 1, over 1, up 1 on both sides of that vertex. And that gives you that nice complete V shape. So here the vertical rise is always 1, as opposed to our quadratic, where that vertical rise was changing by odd numbers, 1, 3, and 5. If we look at this graph, the domain is all real numbers. I get to use every x, there's no restrictions. And the range, if I look up and down, the lowest y value that I go through is 0, and I go up from there. So 0 to infinity, including the 0. The last function that you want to know about is the square root function. This function has a restricted domain because you want to remember that you're not allowed to take the square root of a negative number. So the only x's that I get to use are 0 or positive x's. And that's why this graph is only being graphed for the positive x-axis or right at 0 itself. There's no points over here on the left side of the y-axis. So our domain is 0 to infinity. If you look at the range, the lowest y value we go through is again 0, and I slowly go up from there. So because of this arrow, it will continue to rise. So this range is 0 to infinity. If you like to memorize patterns, you would want to find the starting point of your square root, and from there we go up 1 over 1, then we go up 1 over 3. And that gets us our major points that we want to know about. So up 1 over 1, up 1 over 3. And that gives us 3 good dots that we can graph. Notice here that this time we're going over 1 and over 3 horizontally, as opposed to our quadratic, where we were going up 1 and up 3 vertically. So that's the difference between an x squared pattern and a square root of x pattern. So you would really need to have these 4 major graphs memorized, as well as knowing their domains and ranges. Because in the rest of these notes, what we're going to do is take transformations of these functions and their graphs. Transformations are basically shifts going up, down, left, and right, and we can also use some reflections as well. Reflections over the x-axis and reflections over the y-axis. And those are all the different transformations that we're going to talk about. So let's summarize what some of these transformations look like. If you have a function with a plus k off to the side of that function, that's going to be the same as a vertical shift up k. So for example, if I saw the function x squared plus 1, the plus 1 is being added off to the side of that base graph x squared, so this is going to be a shift up 1. If instead you saw a minus k subtracted off the side, then that's going to be a vertical shift down k. So if I saw square root of x and then a minus 2 off to the side, then this is going to be down 2. If I see a plus k inside parentheses next to that x, then this is going to be a horizontal shift. So instead of going up or down, we're going to go left or right. And the directions for horizontal shifts are kind of backwards from what you would expect. Normally when we see a plus k, we would maybe think go to the right because plus means positive, but actually it's backwards. So when you see x plus k, that's actually going to be a shift left k. So if I saw the function x plus 3 quantity squared, notice first of all how it's different from our vertical shift. We have that plus 3 wrapped in parentheses and it's also being squared as well, as opposed to up here where that plus 1 is off to the side and it's not going to be squared at all. So when you have parentheses, you're going to have these horizontal shifts, and I see a plus 3. Normally I would think that should go right 3, but it's actually going to go left 3. It's going to go backwards from what I expect. If we saw minus k, then we're going to go again backwards from what we would expect. So minus k we think left, but it actually goes right. So if I saw absolute value of x minus 4, then this would be a shift right 4. For reflections, if you see a minus sign on the outside of your function, that's going to be a reflection over the x-axis. And what that does is it flips you upside down. So if I have a minus outside of my absolute value, then this is going to be a reflection over the x-axis. Compare that to the next example where we have a minus inside of the parentheses inside of our function. So for example, square root of negative x, the negative is inside of the square root, then that's going to be a reflection over the y-axis, and that flips you over side to side instead of up and down. So this is going to be a reflection over the y-axis. So just to kind of compare the two, if you know that absolute value of x up here normally starts like a V-shaped pointing upwards, then negative absolute value of x is going to be a reflection over the x-axis, and that's just going to flip it upside down. As opposed to a reflection over the y-axis, if I have square root of negative x, that's going to be taking the original square root graph, which normally looks like that, and reflecting it over the y-axis sideways. So now this square root's going to be pointing to the left instead. So that's the difference between your two reflections, up and down versus side to side. Okay, so now we're going to put all of those into practice. So if we take a look at this first example, we have f of x equals x squared minus 3. The first thing you want to do is identify what your base graph is and how it's being transformed. So the base graph here is x squared. And so what you should know right away is that the graph of x squared normally has a vertex at the origin, and then from there we go over 1, up 1 on both sides, and then from those 2 points we go over 1, up 3 on both sides. And that gives you 5 nice points that you can plot. So that's what x squared normally looks like. Now when I put in this minus 3, because it's off to the side, this is that vertical shift down 3. So that's called your transformation, or sometimes it's called a translation. So our transformation here is shifting down 3. So all we have to do to get that new graph is take this red graph and move every point down 3. So what I usually do is I only move the important point, in this case the vertex. Right now it's at the origin. If I move it down 3, then now it's going to be at -3 on the y-axis. And I'm not changing the steepness or the pitch of the graph at all. So the side points in the pattern that we use to get the side points is going to remain the same. I'm just going to start at my new vertex. So here's my new vertex. From here I can go over 1, up 1 on both sides, and then over 1, up 3 on both sides. And there's my new graph. And the 5 points that I have in blue are the same as the 5 points I had in red, shifted down 3 units. So the graph in blue is the new f of x. What about the domain and the range? How does the domain and range change? Well, for parabolas, what you want to remember is that your domain is always all real numbers, no matter what kind of transformation or shift that we do, because every x is going to be able to be used. There's no restrictions. The range does change. Normally the range is from 0 on up, but because I shifted my parabola down, now I can go as low as -3 on up. So my range is -3 with a bracket up to infinity. Okay, let's try another one. Absolute value of x plus 2. So the base graph is the absolute value function, which is a big V centered at the origin. We go over 1, up 1 on either side, over 1, up 1 again, and we can keep repeating that over 1, up 1, so that we get nice straight lines on either side. So there's what the absolute value of x normally looks like. When we put in this plus 2 off to the side, then as a transformation, that's going to be going up 2. So we're going to take this graph and we're going to shift every point up 2. Now you don't need to shift every point. Just start with your major points like this vertex and move it up 2 units. So now it's going to be at 2 on the y-axis, and then that same pattern will apply over 1, up 1, over 1, up 1 on the left and on the right, and that just gives you a couple of side points, and we have that same V shape. When you're doing these shifts left, right, up, and down, the shape of the graph shouldn't change, just the initial placement of it changes. So we still have our V shape with the same slopes on either sides, but each point got moved up 2 units. What's the domain of this new graph, absolute value of x plus 2? Well, there's no restrictions on what x can be. I use every x, so the domain is going to stay all reals. But the range has changed because I shifted my graph up. Instead of starting as low as 0, now I only go as low as 2. So I go from 2 on up, including the 2 with a bracket. So the first one was a vertical shift down 3. The second example here was a vertical shift up 2. Now we're going to take a look at some horizontal shifts. How do I know these are horizontal? Because the -1 and the +4 are inside of my function, inside of the absolute value symbols, or inside of my square root symbol. So I know that this is going to be a shift left or shift right. The base graph, in this case, is that absolute value function, which we know is that big V shape centered at the origin with side points over 1, up 1, over 1, up 1, over 1, up 1. So that's what normally it would look like. But what we're going to do by putting in this -1 is shift it horizontally, and we're going to go backwards from what we would think. So -1, I think left, but we actually go right. So this is a shift right 1. So again, take your important point, which in this case is the vertex, and shift it right 1. So now it's going to be right here at 1 on the x-axis. The same pattern for that V shape applies. So from the vertex, I can go over 1, up 1, over 1, up 1 on the left and on the right. and that gives me my V shape, and all I've done is shifted every point to the right one. Now in this problem, what's the domain? We shifted it right. Has that changed the domain at all? No, because the domain was all real numbers originally. It's still going to be all real numbers. There's no restrictions on what x can be. For the range, since I shifted it horizontally, I didn't move it up or down, so the range here actually stays the same. The lowest y value I go through is 0, and I go up from there, so my range is 0 to infinity. Okay, for the next example, we have square root of x plus 4. The base graph here is square root of x. Remember that starts at 0, 0, and then from there I go up 1 over 1 to go through the point 1, comma 1, and then I go up 1 over 3 to go through the point 4, comma 2. And it's this arcing shape just like that. So there's your square root. There's no negative x values that get used. So what does this plus 4 do? Well, again, it's going to be a horizontal shift because it's inside of the function. When you see a plus, you think go right, but we actually go backwards. So this is going to go left 4. So take your important point, that starting point at the origin, and shift it left 4. So now it's going to be at negative 4 on the x-axis. The same pattern that I used to get these two side points are going to be used to get my two side points over here. So from the starting point we go up 1 over 1, and then we go up 1 over 3. And there's my arcing shape. Okay, it's the same as just taking these points here and moving them all left 4. So since we shifted left here, we do have a new domain. Before, the domain was only the positives or 0, 0 to infinity. But now my graph starts over here at negative 4. So the smallest x we get to use is negative 4, and then I continue on to the right, so this is going to go to infinity. So my new domain is negative 4 to infinity. For the range, I didn't move up or down at all, so my lowest y value is still 0, and I go up from there, so my range is 0 to infinity. Okay? On the next few examples, we're going to mix a lot of our transformations together. So we're going to have more than one transformation going on at a time. So on this first example, we have parentheses x minus 2 squared plus 1. So first thing you want to identify is what is the base graph that we're starting with. And because of that square, I'm starting with an x squared graph, which has a vertex at the origin. And to get some side points, we go over 1, up 1 on the left and on the right, and then over 1, up 3 on the left and on the right. So there's what a typical x squared graph looks like. Now what are we doing to it? Well, we have a minus 2 and we have a plus 1. The minus 2, because it's on the inside of our parentheses, this is a horizontal shift, and thinking backwards, this minus 2 is actually going to go right 2. Then the plus 1 is off to the side outside of this square, so that's a vertical shift, and this is going to go up 1. So those are my transformations. Now what we're going to do is take that vertex, which is normally at the origin, and we're going to apply these two transformations to it. So I'm going to take the origin, and I'm going to move it 2 to the right, and then up 1. So my new vertex is at 2, 1. Once I know where my vertex is, I can use my pattern to get some side points. So from the vertex, we're going to go over 1, up 1 on the left and on the right, and then over 1, up 3 on the left and on the right. So we get 5 nice points, and here's my new parabola. What's the domain of this new parabola? Well, remember, for an x squared function, no matter what transformations you apply, the domain is always all real numbers, because there's no restrictions on what we can use for x. The range will change. Normally the range starts at 0 and goes up from there, but this time, because we shifted up, our lowest point is at a height of 1, and we go up from there. So my range is 1 to infinity. Okay? Let's try another one. Absolute value of x plus 3 minus 2. So the base graph is absolute value of x, which is a big V centered at the origin, over 1 up 1, over 1 up 1, over 1 up 1, over 1 up 1. So we get this nice V shape. Then when we put in this plus 3, it's inside of the function, so that's a horizontal shift. It's a plus 3, which means we're actually going to go left 3. The minus 2 on the end, outside of the function, is going to go down 2. So let's take our vertex, which normally is at the origin. We're going to shift it left 3 and down 2. So the new vertex is at negative 3, negative 2. Once I know where the vertex is, we can use our pattern. Over 1 up 1, over 1 up 1, over 1 up 1, over 1 up 1, and we get our nice V shape. What is the new domain of this function? Well, I'm using all x's because I'm going to extend out because of these arrows on my graph. So the domain is all reals. There's no restrictions on x. And my range is now a little bit lower than it was before. Before I went as low as 0, now I get to go as low as negative 2. So I start at negative 2, that's my lowest point, and I go up from there, so minus 2 to infinity. Okay, on the next two examples we're going to do those reflections again a little bit more carefully. So on this function here, the base graph is an absolute value, which we know is that V shape. And what a minus on the outside does, remember, is it's a reflection over the x-axis. So this minus sign is a reflection over the x-axis. So that's going to take your origin and flip it over the x-axis, which is just going to keep it at the origin. But if you had a point like 1, 1, and you flip that over the origin, now it's going to be at 1, negative 1. Similarly, if I have a point at negative 1, 1, when I flip that over the y-axis, now it's going to be at negative 1, negative 1. So we basically just get this same V shape, but upside down. So what's my domain here? The domain is all reals. I use every x. There's no restrictions. And my range, this time, before it was 0 to infinity, this time notice that I start way down here at the bottom at these minus infinities, and the highest point I get to is 0. So this time our range is a little bit backwards from what it normally is. We're going to go from minus infinity up to 0 and stop at 0. We don't go any higher than 0 on this blue graph. So there's my reflection over the x-axis. It just flips your graph upside down. Okay? If we have the minus sign on the inside of the square root, then this is going to be a reflection over the y-axis. So normally, square root of x starts at 0, 0, and I go up 1 over 1 to go through the point 1, 1. And then from there I go up 1 over 3, so that I'm going through the point 4, 2. And here's that arcing shape of a typical square root. When I put in that minus sign, we get that reflection over the x-axis. So that's going to take this whole graph and it's going to flip it over the y-axis. So 0, 0, when you flip that over the y-axis, it doesn't move. That starting point actually stays at 0, 0. But this point here at 1, 1, when I flip it over the y-axis, now moves to 1, negative 1, negative 1, 1. And this point over here, which is at 4, 2, is going to flip over to negative 4, 2. So you get the same arcing shape, but it's going towards the left this time instead of going towards the right. So what does that mean about our domain? What's the new domain of this blue graph? What x's do I use? Notice here I'm only using negative x's or possibly 0. So our domain is minus infinity to 0, and because I use 0, I get to include it. So instead of the positives, I'm using the negatives. For the range, that doesn't change. My lowest y value is 0, and I go up from there slowly, but I do go up. So my range is 0 to infinity. Okay, our last two examples here are going to put all of these transformations together. So if we look at this example here, the base graph that I have is the square root graph, which we know starts at the origin, goes up 1 over 1, and then up 1 over 3. So we get this nice arcing shape. So that's the basic graph that we're going to move around. So let's see what different movements we're going to make. The minus sign on the outside is going to be a reflection over the x-axis because it's on the outside of our function. The minus 1 on the inside of the function, because it's on the inside, that's a horizontal shift. So think backwards. A minus 1 is actually going to shift us right 1. And then the plus 2 on the end is going to shift us up 2. So here's what you want to do. When you have all these different transformations involved, always start with that base point and see where it's going to move to. So normally we have our base point starting at 0, 0. When I reflect that over the x-axis, that doesn't move it. When you're already on the x-axis and you're reflecting over the x-axis, you're going to stay put. So the starting point initially is not going to move because of the reflection. But it will move right 1 and up 2. So if I go from the origin and I go right 1, up 2, then my new starting point is at 1, 2. Once you know the new starting point, you're basically done with your two horizontal and vertical shifts, but we have to now take into effect that reflection. So if we're going to reflect over the x-axis, normally our pattern would tell us to go up 1 over 1, up 1 over 3. Think about what that pattern is going to do if we're being flipped upside down. If we're being flipped upside down, then instead of going up and over, we're going to go down and over. So if my starting point is at 1, 2, then we're going to want to go down 1 over 1 to the right and down 1 over 3. So it's the same pattern, but instead of going up, we're going down and to the right. So it's the same arcing shape, but it's going sort of upside down instead of up. Okay, so here's what our new graph looks like. I took the origin, I shifted it right 1, up 2, and then I used my pattern for square root, and instead of going up 1 over 1, I went down 1 over 1 and down 1 over 3, because that reflection is going to make me go down instead of up. So the blue graph is now the combination of all of these different transformations. So let's see what the new domain is. Look at your x values here. What is the very first x value that gets used? The x value of the starting point right here is x equals 1. And I don't use any x's to the left of that. So my domain has to start at 1, and then because of the graph going off to the right like this, my domain continues to infinity. So the domain here is 1 to infinity. The range, look at what happens here. Because we got flipped upside down, we're going to go through all these negative y's slowly but surely. And what's the highest y that we get to? The highest y value of this starting point is at 2. So I don't want to go any higher than 2. So my range is minus infinity up to 2 with a bracket around the 2. Okay, so that has a lot of stuff going on in it. Let's try one more. The last example here, our base graph is that absolute value function, which is normally a v, starting at the origin, going up 1 over 1 on both sides. And what we're going to do to it is we have this minus sign on the outside, which remember is a reflection over the x-axis because it's on the outside of your function. And that is basically going to take this v and shift it upside down. Okay? So instead of going up 1, or excuse me, over 1, up 1, over 1, up 1, over 1, up 1, we're going to be using that same pattern but going over 1, down 1, over 1, down 1, over 1, down 1. Okay, so that's how the reflection gets used. We also have a couple other shifts. The plus 5 is on the inside, so a plus 5 actually means we go left 5. And then a plus 3 on the end means we're going to go up 3. So start with that vertex. A reflection is not going to change the origin. It's not going to move that point at all. So we don't need to move because of the reflection, but we do need to move left 5 and up 3. So the new vertex is at -5, 3. So that takes care of the shifting left and right and up and down. Now we just have to use our reflection to tell us which way to use our pattern. Because we want a reflection over the x-axis, that means instead of going over 1, up 1, we're going to want to go over 1, down 1. So from this new vertex, we're going to go over 1, down 1, over 1, down 1 on the left and the right, over 1, down 1, over 1, down 1, and that gives us a few side points so that we can connect our graph pretty confidently. So here is my new graph. What is the domain of this new function? Well, for absolute values, there's no restrictions on what x's you can use. The only function that has a restricted domain was that square root graph, because you don't want to take square roots of negatives. So absolute values, squares, we don't have to worry about those. Those are going to have a domain of all real numbers. For the range, because we got flipped upside down, I'm going to go through all these negative numbers and go no higher than this vertex, which is at a height of 3. So my range is -infinity up to 3, and I get to include the 3 with a bracket. Okay, so these are the kinds of examples that you're going to have to be able to do. Identify what your transformations are that are being applied, and then use them to graph a new function and find out what the new domain and range are. That concludes our lecture on transformations of functions and graphing. Good luck.